Hello, class. This section is on comparing characters and strings. It says that relational operators can also be used to compare characters and string objects. Okay, so earlier in this chapter, we learned to use relational operators to compare numeric values, the numbers and the variables that held number values. Okay, they can also be used on comparing characters and string objects. So we can compare single character values, and we could also compare a string variables, all right, values. So comparing characters, okay. As we've learned in chapter 3, characters are actually stored in memory as integer. Remember, we said that the letter A, the ASCII value. Remember, we talked about ASCII in the ASCII table. The ASCII value for A as a character is A, but as a decimal value, it's 65, and B was 66. So if we go here to the ASCII table, we can look here and we can see the decimal value for the letter A is 65, right? The character value is A. The character value B is actually 66. So this is how we use the ASCII table so that we can compare characters to see which is greater than the other. So if we look here, we can see that the uppercase letter A is 65 in decimal, whereas the lowercase a is 97. So the lowercase a would be greater than the uppercase a, right? And we'll see that in our program in a little while. So let's get back to our notes. But before we do that, if you notice, every single character that you can type on the keyboard is actually listed in this ASCII list. Now, IBM came up with this extended ASCII code because back in the day we had these characters here and these other special characters where you can actually create design screens and whatnot. But like I say, we normally basically deal with the standard ASCII table. Okay, so let's go back to the notes. So here, and if we look here, this table shows that the character value for 0 through 9 is 48 through 57. Character value of A through Z would have an integer value of 65 through 90. The character value for lowercase a through lowercase z would have a ASCII decimal value of 97 through 122. A blank would be 32. A period is 46. But we know that all these different values or keystrokes would have a value. So let's look for the blank in the ASCII table. So if we look at the ASCII table, I think blank was 32. See here, a space. A space is a blank. Value 32. All right. The period is the period 46. Okay. So it's just showing you that those are the ASCII decimal values for these character values. Okay, so it said noted that every character which we just talked about, even the blank, has an ASCII code associated with it. Right. Notice also that the ASCII code of a character representing a digit such as 1 or 2 is not the same as the value of the digit itself. So don't get confused. If I try to put in my program a zero in single quotes, then I'm not actually trying to check the value of zero. I'm checking the ASCII value, which would be 48. So you got to keep that in mind. All right. So it tells us in comparing them, when two characters are compared, it is actually their ASCII value that is being compared. So when I compare A to B, I'm comparing 65 to 66, even though we, as humans, we see the ASCII value, ASCII representation, the character representation A and B. All right. So here is A less than B. That is true because what? 65 is less than 66. That's all this is saying. All right. So look at this. Likewise, is 1 less than 2? The ASCII value of 1 is less than the ASCII value of 2. Yes, it is. All right. So 49 is what? Less than 50. Okay. So this is the table. Table 411 shows the lowercase letters that having a higher ASCII value than the uppercase letters. All right. So the lowercase a would be greater than Z. Lowercase a would be greater than any of the what? Uppercase values. Right. Remember we looked at the table. If we go back to the table, all of the uppercase values are what? From 65 through 90. So the first lowercase value start at 97. So any lowercase value would be greater than any of the uppercase values. Okay? So keep that in mind. So let's look at this program and then we'll write our own little program. So if we look at this, it says this program demonstrates how characters can be compared with a relational operator. All right. So here we have a variable declared as ch. All right, char ch. Now, looking at this, at statement 11, at line 11, it says enter a digit or a letter, and then we got what? Ch equals cn.get. All right. So we're going to have to input a value, okay? So we input a value, and whatever value we input is going to ask if ch is greater than or equal to, and notice we're checking for the what? ASCII value. 0, not actually 0, but what? The ASCII value of 0, which was what? 48, all right? So it's asking us, but we inputted a character, so it's going to check that character. So it's going to check from 0, the ASCII value for 0 through 9. And if it is, it's a digit. It's going, and if not, it's going to check to see if the ASCII value is from as A, uppercase A through less than uppercase Z. And if it is, we know it's an uppercase letter. Then we checking to see if the value we typed in is from lowercase a through less than the lowercase z. And if it is, then it's a lowercase letter. And then otherwise, we're going to output, you did not enter a letter or a digit. All right, it's everything that's outside. Remember, it would be everything from here on and everything from here on. All right. Well, minus the what? The numbers too. So it could be up in here, and it could be something up in here and this. Okay. So look at this. So when they entered a lowercase t, it said you entered a lowercase letter. When you entered a uppercase v, it said you entered an uppercase letter. When you entered the number 5, it said you entered a digit. But then when they entered an ampersand, it's not a letter, uppercase or lowercase, and it's not a number. Okay, so let's look at online GDB. So in online GDB, we could say something like char letter. All right. And then we could say CN. We could do CN letter. All right. Oh, before I do a CN, I have to do a C out, right? C out. Please enter a single character. All right. So now, then I could say something like, and I'll just do the uppercase. All right. Okay. I'll say if letter what greater than equal to 65, and then I'll say and letter less than or equal to. Remember we said the greater than equal to, and then with the and less than equal to, we're checking for a range in between those. All right. So let's go back 65, and what was the table for the uppercase 65 through 90? All right. So what will we do? Less than or equal to 90. All right. So if that is the case, now we could say C out. You've entered an uppercase letter, all right? All right. But otherwise, we'll output or I'll just say you did not. All right. All right. So we have this. All right. So looking at this, char letter, okay. See out enter a single character. All right. We see in a character, and then we say if letter is equal to 65. All right. So whatever letter we input, if it's ASCII decimal value is from 65 through 90, then it will output you have entered an uppercase letter. If it's less than 65 or is greater than 90, then it would be and it would not be an uppercase. All right. So let's run this. Okay, let's run it. Let me drag this up. Let's run it. Hopefully all the arrows out. And so say we'll enter G, all right? We enter G. You have entered an uppercase letter, okay? So let's run it again, all right? Say we put in the @ symbol, all right? You did not enter an uppercase letter, all right? Let's run it again, okay? Let's enter the letter M, okay? Lowercase m, and hit enter. You did not enter an uppercase letter. So any value outside ASCII value, outside decimal, that's outside of 65 and 90 would be considered not considered an uppercase value. Okay? All right. So that's how we compare our characters. All right. So let's go back to our notes. Okay. So now comparing string objects. Now a string is what? Could be one or more characters, consecutive characters, right? So now you have a string, okay, a series of characters. That's what a string is, right? Your name is a string. All right. Address is a string. So a string is a series of characters, whereas our char values was what? Single characters. All right. So comparing string objects. String objects can also be compared with relational operators. Okay. As with individual characters, when two string objects are compared, it is actually the ASCII value of the character making up the strings that are being compared. Okay, so now it gives an example. We have uh, string str1 equal ABC, string str2 is equal X, Y, and Z, right? So the string object str1 is considered less than the string object str2. Why would that be? If you compare the first two, A is less than X, correct? So that would automatically make the what? Make that particular value less than the string, less than this string. Okay, so it compares each one. So once you find the first one that is less than, that automatically defaults it to be less than the other. All right, because it's going to compare each one, and further down we'll see that. So it tells us that string one is considered less than string two object because the characters ABC alphabetically precedes, okay, which has a lower ASCII value than the characters X, Y, and Z, okay? So the following statement will cause the message str1 is less than str2 to be displayed on the screen. So look at this. So if str1, which is what, ABC, is less than str2, which it is, by default, it will output str1 is less than str2. All right. So let's see how it go about determining how it's less than. All right. And we kind of mentioned it before. So one by one, each character in the string, all right, is checked. Okay, in the first operand is compared with the character in the corresponding position of the second one. All right. If all characters in both strings object match, obviously the two strings are what? Equal. Okay. Another relationship can be determined if the two characters in the corresponding positions do not match. Okay. If the first operand is less than the second, all right, then the first and it does not make the second. Okay. The first operand is less than the second operand if the first mismatch character, if the first mismatch character in the first operand is less than the counterpart in the second operand. So, and you just continue on till you find, till you complete the string. So let's look at this example here. All it's saying that I check Mary against Mark. So I'm trying to find out if I could check to see if they both equal, all right, or if one is greater than the other. So here we got string name one is equal to Mary, string name two is equal to Mark. So if you look at these, which one is greater? Okay, Mary would be greater because Y is greater than K. So we say M and M, they're equal. A and lowercase a, they're equal. Lowercase r, they equal. So up until this point, those two strings are equal. But when you look at this one, this position, lowercase y is greater than lowercase k, so therefore Mary would be greater than Mark. Okay, and so that's all this is saying here. Once we get to this fourth position of in this string, y was greater than k, and therefore that would make Mary greater than Mark. All right. So it says, given this, okay, what we just found out, Mary is greater than Mark. So look at this. Is string 1 greater than string 2? Yes. Mary is not string, but name 1. Mary is name 1 and Mark is name 2. So name 1 would be greater than name 2. All right. Is name 1 less than or equal to name 2? That would be false because name 1 is greater than name 2. Now, look at this last one. Is name 1 not equal to name 2? That would be true because what? Mary is not Mark. The name Mary is not the same as the name Mark. So they are not equal. Okay. So string objects can also, of course, be compared to string literals. And what they mean is something I write out in double quotes. Okay. So I can ask if name 1 is equal to, and then I can put the double quotes and I could put Mary, okay, rather than using a variable, okay? So that's all they're saying now. So let's look at this program and then we'll write a program. So looking at this program, it says that the program uses relational operators to compare a string entered by the user with valid stereo part numbers, okay? Now that's a key thing, valid stereo part numbers. Because of what? If I put an invalid part number in here, I can't determine the cost, all right? And let's see if the program, and the program tells us if we input an invalid part number. So let's look at this. So we got a constant price for the first item, and we have a constant price for the second item, all right? So now what happens is we have a string, a part number, which is a variable, and we made it of data type string. Now remember, when you use string in your program, you have to what? You have to load the what? The string header file. Remember, sometimes y'all run into that issue of getting errors. You have to do the pound include string when you're actually using a string variable in your program. So now we have string part number, okay? And this is gonna allow us to hold the part number in that particular variable. So here where we displaying the options for the user. So it says see out the stereo part numbers are. So it give you the description of the item, and then it gives you the part number S-29A. It gives you the description of the item, and then it gives you the part number S-29B. So then it gives you the opportunity to enter the part number. So you're going to be prompted with enter the part number of the stereo you wish to purchase, and then what? CN part number. So now you'll enter the part number, and what are the valid part numbers? S-29A and S-29B. So when if I enter S-29A, then I could say if part number is equal to what? S-29A, all right? Then we're gonna see out the price, which was a constant price for that part number. If the part number entered was S-29B, we have a constant price number for that. Constant price for that part number, and it will see out the price number is, and it'll print that constant value, which was up here. Remember, we had const price A, and const price B. So those are the two prices that it's going to choose from. If you happen to add an extra character or did not type all the characters or have a space at the end or either type the part number incorrectly, then you would get this output. Part number is it would output whatever part number you outputted, and it would say is not a valid part number. Okay, so that's what you would get. So this is just showing you an example of what would happen here. Like you get this output, then you would get enter the part number, and you would enter a part number, hit enter, and then it will give you the price. Okay, so let's look at online GDP. So let's say we change, we add string. So we'll do pound include string. All right, so now I will change this to string. Now, okay, if I do this now, and I'll say CN, then I'll do the get line. All right, so now I'll say please enter, I'll say name. Please enter name. All right, and so here, what I can do is I'll change this to name. Keep you from being confused. See, enter name 1. All right. And what I'll do something like this. String name NM is equal to, say we say a name, say Billy. I'll put that. All right, Billy. Now, so NM is equal to Billy. So string name. And I'll say, please enter your name. All right. And then I'll have to do what here? Well, I could do a CN, but I'll do the get line. All right. Okay. So now, I'm gonna get the name, and now this one just allows me to get a name with blank spaces in it, but it doesn't matter if I hit enter with a whole name, it doesn't matter. But it allows me to get whatever name they put in, the entire name. All right. So now here I would say here if name 1, I messed up here. All right. So if name 1 is equal to NM, so I'm checking to see if the name is equal to Billy. All right. So if name 1 is equal to Billy, then I can say I can take this out. I can say hello. Oh, I would do it a little different. I'll say hello, and I'll do name 1, right? So that's gonna just say hello, Billy, okay? And then I can do hello, Billy. All right. Otherwise, I could do an else, and I'll put all right. So sorry, you're not who I'm looking for, or something like that. So now when I run the program, all right. Hopefully all the errors are out. Did I run it? All right. Got an error. Oh, I got if and if. Oh, here we go. All right. So run it. All right. So now say I'll type Bill, right? And see what it say? Sorry, you are not who I am looking for. If I run it again, all right, and I'll type Billy. Hello, Billy. All right. So see what happens is it can take that string value that was inputted through this CN and compare it to NM, and to see if if those two values are equal. Right. But watch this. I'll run it again. And some of you may have had this happen to you before. I'll type Billy and I'll put a space. Just, because sometimes when we typing, we have a tendency sometimes to hit a space bar. And if I do that, then what? B, capital B, I, L, L, Y space is not equal to capital B, I, L, L, Y. So it should give me, see, sorry, you are not who I am looking for. So you got to be careful, you know, when you're typing in data. Many of you got that error when you was registering with the attendant. You typed in your name and you put a space bar and it told you something about a non-alphabetic character. All right. Okay. So now watch this. I could kind of disregard this altogether, and then I could change this to that string literal. Remember we said I could compare it to a string literal, and I could put double quotes and put Billy in here. Rather than use a variable, I can actually put a string literal here. So now I'm comparing name 1 to this string literal Billy, all right? So once I input Billy here, all right, and it compares it to Billy here, it should give me this as the same result. So I run it, and see if I type Billy, see, I got the same results. All right, same results here. All right, so let's well, we're back in the program, but that pretty much concludes comparing strings and also comparing character data.